Two better, too bad.
How much for a 2-bed to buy?
1,000.
Is it?
Yeah, not too bad.
Wait, here?
Hialeah.
Solid. Now you just gotta learn Spanish.
No.
Yeah, bro, you gotta go 30 minutes away from Hialeah if you wanna go anywhere that speaks English.
No, I'm going to Publix and be like, that one.
Poking the glasses.
I got a Spanish-English book.
Yeah.
That's like a mile away from this dude's house. I was over in Miami Lakes. Go over the bridge. Where am I at? I'm in Hialeah now. But like a couple weeks ago, a little J12 here on the scale.
How's that coming?
It's okay. It's okay. I just got the parts in yesterday. I got the boat registered. That was fucking $400.
Yeah.
Dude, registry in Florida is so for anything.
Yeah, and I hadn't even registered the show
It's
yet.
so stupid.
Like 150, but yeah. Yeah, right? I'm trying to take this thing around now.
There's no registered votes back home. None.
Yeah, but you're not paying property tax.
Huh?
But you're not paying property tax. I've thought about moving my car down here
Pull up on a
and
steel boat.
avoid that fucking yearly tax bill.
And we're supposed
I
to
don't
register
understand.
clear with the fourth if we're running offshore.
I only have my yearly, a couple grand for my job that I have to file taxes for. I don't really understand property taxes or anything like that.
Like in Kentucky, I have to pay every year on my vehicle to get a sticker.
Seriously?
Good morning, guys.
Good morning.
How are you?
Good, how are you?
Nice to see you. You see the videos yesterday?
What was yesterday?
Yep. Not yet?
I'm all caught up, I think.
Okay. Today we are going to talk about the inverters. How magic is the inverter?
Professor,
What do you? Excuse
can
me?
you draw the picture of the relay real quick with the bilge pumps? Like,
The bitch pump. Okay.
yeah,
Never let that guy.
the alarm. The alarm.
I'll never let that go through those things.
Yeah. Leave my shit.
Should stay there.
Wow. It was like half. There's like 5 people missing.
Is it?
Yeah?
So they're like 2 of them literally can't be here on that.
Where's Brian?
Or Dalton, the a.c.r was still left.
That's true. I didn't even count Dalton part of it.
One of them takes a train.
True.
So he's like, yeah, that was like for day 1. They were like,
That's true. Yeah.
A train.
Yeah.
Like the one over.
Yeah, the Amtrak or
Okay.
the Tri-Rail.
And this is the pump, the negative.
We can get like a month.
And this is the. Okay. We are going to refresh quickly the connection of the bilge pump. The power is coming from the positive bus bar. The power pass for the fuse. The power after that enter in the middle of the switch. You remember? The switch have a automatic position here, manual position here. In automatic position continue into the flow switch. After the flow switch enter in the pump. In automatic, in manual position, the power goes directly here and is mixed over there. Clear? Yes or no?
Yes.
All right. And the light. We are going to put the light here at the same time with this, and this one will be the ground of the light bulb. No? Good. Somebody said, I wanna install a horn, an alarm, especially when the bilge pump is working in automatic, for example. Okay, I'm going to install the horn here, and the horn have a negative and positive. Okay, the procedure to install the horn is after the flow switch, with the positive here in this point. No? And of course, when the flow switch is activated, the horn turn on, indicating that the pump is running. Also, if you select manual position, the current pass over there activate the horn and activate the pump. You said yesterday, oh, I want to install a relay for the horn, but really it's not necessary because for in what scenario you need install relays? In what situation you install relays? For what reason you need relays?
Ignition.
When you want to do multiple things with one thing.
Reverse motors?
Excuse me?
You can reverse motors with relays.
No, the relays. The relays is a switch, remotely activated. But in what case I need a relay? For what reason I need a relay?
Ignition.
Because I don't need
Multiple.
send the signal constantly. Only if some situation occur. No, this is the relay. You remember yesterday the example that I put with 7 relays, and I said, okay, when I activate ignition switch, I send different signals to activate this sensor, this pump, this sensor, yeah, with different signals. When I turn off the switch, no signal for those elements. That's clear. In that case, you don't need a relay, and it's impossible to install a relay because this is not a, no. Let me, the days pass, and I will show more application of relays, and you understand, oh yeah, now I understand why the relay is necessary in that point. The relay is necessary only when you have the control of the situation. Oh, I have the control of the situation here. Okay, I put a relay to protect that circuit. I use the relay in the normally open position for that element, or in the normally closed for that, because I need kill. When I activate the switch, I need kill that motor that is running permanently. No? Depending how you use the relay, in normally open or normally closed, is the situation. But in this particular case, you don't need relay. It's not necessary a relay. Be careful with the installation of the bilge pump, because this switch, the switch for the bilge pump, that one. Remember that one? With the manual automatic that you install. This one, the input power in the middle is coming directly from the positive bus bar. It's not coming from a main breaker. You don't have a main breaker in the DC panel with the label bilge pumps. No. The bilge pump have power all the time. And the bilge pump works in automatic with the flow, or in manual if you apply manual. With that switch is independent of the panel. Alright? The bilge pumps receive constant power all the time.
What if you have multiple bilge pumps and you want to wire to that one horn?
If you have this is the idea. If I have a constant positive bus bar, I can install other bilge pump here with other group of elements. And if this one is broken, because the fuse is broken, this one is running.
Yeah.
And I install other one here, yeah, because it's coming from the constant positive bus bar.
But how can you connect it to the horn if you want, like, all the bilge pumps, when you hear one turn on, that the horn turns on as well?
To use only one horn?
For all of them, yeah.
Oh yeah, but I need a
Well, to be honest with you, you would not want to hold the bilge pump. You would add a separate flow switch for the horn. Like if it goes past the bilge pump, then the horn goes
High
off.
water on.
High water.
And then everyone's gonna be complaining to you, man, every time the horn's constantly going off.
Yeah.
Because there's always bilge, especially when you take off, all the water rushes to the back of the boat, the boat pumps the water out. Then you're gonna have a horn every time. So you only put that. Normally, what we do is we have the bilge pump, and then I go probably maybe a little bit over the bilge pump itself. Like you see this bilge pump here. Install another one like this that controls the horn. So if the water's past this, there's a major problem. Then it warns you. But if you have a horn every time a bilge pump goes off, the guy's gonna go, man, it's gonna cut that horn off.
Can you wire the horn to like a breaker to turn it on and off with the pump?
You just put it right to the flow.
But what if you have like 6 bilge pumps? You have to have 6 of those?
You can do is you could put it to a bus bar, and have the horns, each horn, like if you have one in the front, you can put a high water alarm horn in the front, in the back, and it all goes to a bus bar, and the bus bar feeds the power to the horn. You're not gonna need 6 horns, you just have one horn. So when the horn goes off, you're gonna have to investigate which side it is. If you hear the high water alarm horn, you're gonna wanna go and see where the water's coming from. But you're not gonna want 6 horns.
To install only one horn for different bilge pumps, it's necessary create a circuit board with diodes. If not, the horn will be activated constantly. Let me a couple of weeks when we explain diodes and I explain how to do that circuit.
It's electronics class.
Because yeah, in electronics. Because in this moment you can install a horn individual per each bilge pump. But if you want only one horn, that is a good idea. You need to create a circuit with diodes to protect the other one. If not, the horn is activated all the time. Okay? Wait a little, and I explain it. Remember me in the chapter of diodes, I do the picture.
In electronics?
In electronics.
Which is the next one after this.
I know you have a lot of questions, but every day.
It's good you have questions.
Yeah, this is the idea, no?
Shows that you guys want to know.
Yeah. Okay. All right. Inverter. Okay, guys. Inverters. What is the difference between this equipment and this one? This is the battery charger, and this is the inverter. This one, the input is AC, and the output DC. Okay, what is the other name of this element? AC
Rectifier?
input and DC output.
Correct.
What is the name of this equipment?
Rectifier.
Rectifier. The element that you have to charge your cell phone, you plug it on the outlet 120, and the output is 3 volts, 3.5 volts DC, no? To charge the cell phone. This is other rectifier, no? Yes or no?
Yes.
The alternator produce DC power, and internally have a group of diodes to rectify the AC current, you remember? Into DC, the rectifier. Okay, the battery charger is a rectifier. And the marine battery charger is a sophisticated rectifier. The circuit board is a perfect circuit board, and the DC output signal is perfect. The DC output signal coming from the rectifier is exactly the same DC signal that you have in the battery when you read the voltage between positive and negative. It's not similar, it's exactly the same. For that reason, with a good battery charger, I can charge a battery, no? I can recharge the battery. It's clear? Oh, can I charge this battery with the charger of your cell phone?
No.
Yeah, you can, but you spend 27 days charging that battery, or 30 days, or 40 days, because how much amps produce your charger of your cell phone? It's 2 amps, 1 amp, no? And how much amps have this battery? 100 amps. You need 100 days, no? To charge this battery. Yeah, you can, but you spend a lot of time. Can I charge this battery 100 amps with a battery charger 10 amps? Yes, but I need 11 hours. You see? It's 10 times. Okay. Depending on the capacity in amps per hour, I charge the batteries faster or slow. Yeah? Right? Okay, this is the battery charger. And what about this? This is what?
Inverter.
What is the difference with the battery charger? In this one, the input is
DC.
DC, positive and negative. And the output is
AC.
hot, neutral, and ground, AC. Oh, nice, no? But this one is more sophisticated because this one converts this signal into that. Oh, wow. You remember that signal was possible because the rotation of the magnets in front of the coils, no? when each positive and negative pass in front of the coil, one cycle is produced. Okay, with rotation of electromagnets, it's easy to produce AC signal. Where is the rotor and the stator here? Nothing. How they create that signal is simulated electronically, is simulated in the circuit board with the computer. For that reason, at the end, the output signal is not a perfect sine wave. It's a little square, a little triangle, it's not perfect. It's simulated. Anybody follow me? For that reason, you see in the label of the battery charger, perfect output signal. It's not perfect. It's, okay. The more expensive the inverter, the best quality of the output signal. Pretty close to the real, but it's not real. They say in the label real signal. It's not real. It's approximated. It's a good approximation. This inverter is for 4 kilowatts, 4,000 watts. And the price of this one, $7,000, $8,000. That. It's a lot of money. Wow. Oh, Mr. Lopez, but in Harbor Free, there are inverters for 4,000 watts, $350. Oh, yeah. Can you bring that inverter? And we connect the oscilloscope, and we check the output signal of this and the output signal of the other one, $300. The output signal of this is practically a real sine wave. It's pretty similar. It's a little square, but it's pretty close. And this one is a triangle. It's not a sine wave, no? Okay, I have a question. For example, I have an electrical drill or a blower or a fan. Can I connect the fan in the output of this inverter?
Yeah.
Yes. The signal is. Can I connect an electrical drill in the output of this? Okay. In the Mickey Mouse inverter with the triangle signal, can I connect a drill?
Yeah.
Yes, but the drill works at low speed, and in 10 minutes the drill is too hot, and suddenly the batteries are completely drained in the triangle inverter. You understand? That signal is not good. But let me explain. It's not only because the signal is not perfect. This is one reason. The other reason is this. You remember how you calibrate the frequency in a generator? With the RPMs, no? With the RPMs at the governor or with the RPMs of the carburetor if it's gasoline, with RPMs, no? More RPMs, more frequency, less RPM, less frequency. It's clear, guys? Okay. This element creates a fictitious simulated AC signal. However, that signal created in the computer simulated signal doesn't have frequency, no frequency. It's impossible because it's not created for rotation of magnets in front of a coil. This frequency is also fictitious. I am going to explain how is the technique to convert the DC signal into AC signal. Okay, ready? You bring the brain and the pencil, different colors. Okay, this is the idea. Suppose that I have a DC signal, 12 volts or 24 volts. And this is the negative portion of the signal. And this is the positive portion of the signal. I am going to do this. I am going to interrupt the DC signal. I am going to cut it portions of DC signal interrupted. This is the step number 1. I am going to cut it portion of a DC signal. You remember when I explained the procedure to verify if the alternator in your car is working good or not? What was the Lopez technique?
The light.
I put the car in front of a glass, a window, and I check the intensity of the light. You remember? And I accelerate, and I verify if the intensity of the light change. What happened when the intensity of the light change?
Alternator is bad.
It's because the voltage regulator is not good, no? You remember? And you remember that I said that, what happened if I have my car in front of the glass and I see that the light is blinking?
Bad frequency.
Excuse me?
Bad frequency.
No. Remember that the output of the alternator is DC. It's not frequency. It's DC.
Fluctuation of the voltage.
Excuse me?
Fluctuation of the voltage.
No. It's blinking.
Low output.
Maybe.
It's like interrupted. Yes, no.
But
Bad brushes.
No, I say that this is because in the bridge of diodes, in the rectifier, one diode is broken.
the AC coming through.
Yeah, the AC signal is
Coming through.
interrupted, no? In portion, in segments. Okay, we are going to do the same. We are going to introduce here diodes, and after that capacitors, and we are going to do the same here with diodes and capacitors. And finally, in the output of this, after that, the signal is like this. Is with the diode, I cut it. Sorry, it's not with diode, it's with transistors. Later we are going to talk about that. It's with transistors. And capacitors. Transistors and capacitors, transistors and capacitors. With the transistors, I cut it. And with the capacitor, when I cut it, that portion, I storage that portion in the capacitor. No? I cut it and storage. Cut it and storage. And after that, the signal is interrupted. Okay, now I have a DC signal, cut it, segments. And now I am going to do the magic invention. I have a transformer, isolator transformer, a step-up transformer. This is the frame of the transformer. And I am going to pass this cable, the interrupted cable, the interrupted signal, no cable, the interrupted signal into the primary coil of the transformer. Good? Okay. What happened in the output of this transformer with the signal?
It's times 10.
Excuse me?
Times 10 power.
What happened with the signal? How is that signal?
It's gonna be solid.
It's
The
clean.
output signal will be like this. Because look at this one. And this one here. Yeah, you see? The segments produce that because in the secondary, the second coil received a square signal, but with square interruptions, like this. This is in the output. In the input, you have interrupted positive and interrupted negative. And in the second one, you have that square signal. That's clear? Oh, nice. Now it's square. But what happened? I need rounded. I need a rounded that signal to simulate the sine wave. Okay, they install here, this is the AC output signal. This is the AC output signal. They install here in this I need a long board. They install here in this capacitors. This is the project the first project of the next course is this. In the circuit board, we are going to insert the capacitor, the diode, the transformer, and we are going to rectify AC into DC here. This is the first laboratory of the next class. And after that, with resistors, and once again, other capacitor, and other resistor, finally, the output signal here is like this. Is pretty close, It's not a perfect signal, but it's pretty close to the sine wave with those capacitors and resistors after the step-up transformer. Let me explain what is the function of the step-up.
Increase voltage.
If this one have, for example, 100 turns, this one in the output have 1,000 turns. What happens if the input DC interrupted signal is, for example, 24 volts? How much will be the voltage in the output square signal?
240.
Excuse me?
240.
240 volts. And after that, with the capacitors and the resistors, they rounded the signal a little. That's clear? For that reason, if I want in the output hot, and neutral, and ground, 240, hot, how should be the configuration of the batteries? 12 volts or 24?
24.
24, because the transformer is step up. If I want in the output 120, how should be the configuration of the input?
12 volts.
12 volts. If I have three phases, 360 in the output, how should be the configuration of the batteries?
36 volts.
36 volts. Bingo. This is the inverter. All the inverters internally have a step-up transformer to convert the interrupted DC signal into a square signal. And after that, with those capacitors and resistors, convert in a simulated AC signal. Okay, look. Depending of the fragmentation of the DC signal in 1 second, they simulate in that computer 60 cycles or 50 cycles. Depending how many portions they cut it in 1 second, the output signal will be 60 or 50. But this is not a real frequency. You understand?
Say that again about the frequency.
Depending how many segments they cut it in 1 second, the output will be 50 or 60 or the frequency that you want.
You lose amps though, right? When you have the step-up control?
Yeah, you lose amps. But
Mr. Lopez,
now we are going to talk about
question about, I got a two-phase, how they create three phases?
Excuse me, how to create three phases?
Three phases.
Oh, it's the same. It's basically, remember that you put two input signals with the same negative. Remember that if you have different bank of batteries, you can connect the negative common. You should connect the negative common.
Yeah.
Okay. Suppose that you have one bank of battery configured in 24 volts and other bank of battery configured in 12 volts. Okay. I have, in between this and this, I have 24 volts. And in the other bank of batteries, in between the negative and the positive, I have
12 volts.
I have 12. And now, great question, Andy. And now I have 12 here and 24 here. And in the output, I have 3 phases. Okay. The most common are inverters double phase. No? Pay attention. Today, some years ago, in my classes, 10 years ago, 15 years ago, I said, the inverter is not good. I said some years ago that I don't recommend the inverter. But today, the engineers advance a lot. And the output signal is pretty close to the real signal. And the output frequency, of course, is created in the computer, but is 60, is 50, is great in expensive inverters. That's okay? No in Mickey Mouse inverters. These type of inverters are perfect. Let me explain something. Some years ago, the majority of the golf cars, the traction is 10 years ago, 15 years ago, with a DC motor, reversible motor. You remember? With the solenoid control box. Today, all of those golf cars, the motor is AC, 3-phase AC. And they reverse the rotation with the contactors. And those AC motors receive the AC power from one inverter, and the inverter from the group of batteries. The AC motors are better than the DC motors. Why?
More phases. It has phases, it's more efficient.
It's more efficient. The AC motor run hours and hours, and the temperature is good. The AC motors produce high speed and high torque. In comparison with the DC motors are excellent to produce high torque, but for a short period of time. For example, you remember the motor of the bow thruster. If you use the bow thruster 3 times, what happens if you want to use the bow thruster 4 times? The battery is, because those DC motors drain the batteries completely. Easy. The AC motors are more efficient. The electric cars that you have today in the road, the Tesla and other, there are millions of electric cars right now in the market. The traction motors are AC motors, 3-phase motors. And internally, they have an inverter. And the inverter produces the AC power for those motors, and the inverter receives the power from the battery bank. And the battery bank is fully charged with the solar panels or with a small generator only to charge those batteries. This is the hybrid configuration. We are going to talk next week about that. That's clear, my friends? AC motors are efficient. Today, the new technology in inverters is great. There are inverters with a high efficient, and you can install inverters, excellent quality in your boat. The problem is the price, no? The price.
I saw there were some questions talking about like certain things won't work on inverters, like TVs. Did they have like there was a question talking about black lines were appearing on the TV.
Oh yeah.
When you were using
Yeah. Wait a little. Okay, guys. Until this point, according with this question.
All that stuff is located in
It's here.
So like transistor in the beginning, capacitor, and then transformer, and then same thing again.
We are going to do this one in a small board in 2 weeks. You solder in here, and we are going to connect the plug 120, and in the other side, hey, 12.6 volts, perfect. All right, we are going to do the rectifier. We are going to do that circuit to understand the rectifier.
I have one quick question, only because I don't know inverters. Can you have that signal go through the isolator transformer to clean it up even more?
No, that signal, if you pass that signal to the isolator transformer, internally in this element you have an isolator transformer.
It's inside. Okay, that's what
Yeah, but that signal is clean. You don't need.
You don't need to clean
No,
it.
no,
Okay.
that signal.
There's no-
But you can pass. No problem. You
You
can
can
pass.
do it, but
yeah.
it's not gonna do
Yeah,
much.
but that one at the end, after this, they have other isolator transformers to clean completely the section.
What about the cheap one? With
Oh, the cheap ones.
Could you
sir.
could you do it with the isolator
The
transformer?
cheap ones. No, papi. The signal is a triangle. It's a triangle.
So if you pass it through,
the cheap one through the isolator transformer.
Ah, no. You put the cheap one in the isolator transformer, you have a other triangle in the output, a little rounded.
so
But
what
it's
if you do it
triangle.
through two?
You just keep going with isolator
Isolator
transformer.
transformers.
No, my friend. No, my friend.
35.
No, it's okay. Clear the theory about the inverters?
Yes.
Okay,
Yeah.
pay attention. The secret. Yeah, go ahead.
So the generator is more reliable than.
Okay, yeah. If you ask to me, hey, Mr. Lopez, I have a boat and I want to install. I am not sure if a generator or an inverter. What is your recommendation? Generator. Generator is better. The output signal is perfect, and I don't need calculate the battery bank because okay, I want 6 kilowatts in the output. 6 kilowatts. Oh, let me calculate how many batteries you need in the input. Yeah, depending how much you want in the output, you need a big battery bank, and depending how many hours you want to operate the equipment, AC equipment, the battery bank should be bigger and bigger and bigger. For that reason, my friends, when I have a customer interested to install an inverter in the boat, I say to the customer, of course, my friend, tomorrow at 2 p.m. I will be in your boat, but I need one thing, that your wife be there. Oh, my wife? Why, Mr. Lopez? No, I need your wife. Okay, all right. 2 p.m. with my wife. Okay, all right. Okay, mommy, good morning. Mr. Lopez. Okay, you need an inverter? Yeah, we need an inverter. Okay. Can I see your AC panel? Yes, you see the AC panel. Oh, wow. 12 breakers. You have 3 air conditioning equipment, blowers, lights, water maker. You have a lot of load. You want to supply power for all of those equipment? Yes, the lady, yes. How many hours? 24 hours. Need one more.
Typewriter, bro.
Oh, no! You say 24 hours, all of those. If you want, talk with your husband. Hey, okay, only one air conditioner, only one blower, only one light, only one. Mr. Lopez, this one. Okay. No! Okay. Check again. Okay. Only one fan, only 2 lights, only. Okay. All right. Now, 12 batteries. 12 batteries? Yeah, only for one fan, 2 lights, tan, only 8 hours per day, not 24 hours. You know? Now you understand why you need the family complete with the kids? Because the people say at the beginning, no, I need everything. You need everything. You need 1 million of batteries. You need other boats with batteries.
Battery barge.
Yeah,
Just drag it
yeah,
behind the
that's the and today I am going to explain the procedure to calculate that. Yeah, Papa.
When it comes to the maintenance part of the keeping up the generator and the inverter, that's when the inverter is more reliable because you don't have to lose.
Of course, no.
So the inverter is only for your blender to make cocktails.
For that reason, in some boats,
The most important. Filtron? No.
mega yachts, you see the AC panel and you see some breakers with a mark, with a label, blue label or red label. Those breakers are the only breakers allowed to turn it on when the switch selector is in inverter. No, because Bobby, if you the battery and shut down the inverter. Okay.
What's charging the battery when it's connected?
Oh yeah, right now I am going to explain that. Until this point is clear? Okay, let me explain something about this output here.
Question. So I cannot recall when we connect inverter to the batteries. Do we have to do through the a.c.r. so it doesn't follow?
No. This is a great question. This group of batteries is exclusive for this. Never share this group of batteries, the batteries of the inverter, with the house batteries, and no. This group of batteries should be exclusive. In some sailboats, they share that group with the home with the house batteries. But if it's possible, try to keep a separate group of batteries. Okay. And additionally, you have from the positive of the battery one on-off switch to activate or deactivate the inverter. In other words, one of the ABYC questions is this. In order to start or stop, activate or deactivate the inverter, where is located the switch or the breaker to start that equipment? In the AC panel, option A. Option B, in the DC panel, option C. The equipment has your own switch or doesn't matter, any part. Where should be located?
Close to the
in the AC panel, in the DC panel, or that equipment have your own switch to activate and deactivate.
Your own switch.
That's the own switch. You don't, in any panel, AC or DC, you have a breaker for this. You need to go, open the hatch, and turn on that breaker. That's clear? And after that, you turn on this one. Right?
It protects the rest of the boat. There's a malfunction.
This is completely isolated. However, if you check the majority of the boats, this part is very important.
Oh, please.
All right. Look at this.
That's one spot. It's a really impressive 3D object.
And you have batteries here connected in series or parallel, depending how much voltage you wanted in the output. You configure the batteries in series or parallel, no? And here you install the switch selector, and the other one is the negative here, and in the output, you have a, I am going to make an amplification of this. You have this board. You have a hot, out, hot, out, neutral, out, and here in the bottom you have neutral in, hot in, and hot in. And you have the group of breakers, you remember? One of the breakers is for inverter.
Make sure you guys pay attention how you're going to wire those boards as far as the breakers.
if it's double phase, you have this one. And this is the neutral. Yes or no?
Sure.
Okay. This is the situation. And you have the AC panel here. The AC panel with the main breaker, and the main breaker receives the and after that you have the breaker. You remember, guys? And in the bottom you have the neutral bus bar, and here you have the ground bus bar, no? Okay, and here you have the neutral in the middle, and you have the hot here, hot number 1, and you have the hot number 2 here. And after that you hit the breaker. Yes or no? This is the situation. And you have a question. Who charged those batteries?
The inverter.
I have an external battery charger dedicated for that group of batteries?
No.
Or internally here, they have a small battery charger dedicated for this?
Yes.
Yes. Internally, this element have a small battery charger dedicated to charge these batteries. For that reason, in the AC panel, you found that one breaker, and the label of the breaker is inverter / charger. Inverter / charger. What is the function of that breaker? Start the inverter
Start the charger, the battery charger.
is only activate the internal battery charger for that group of batteries. This is not the breaker to start or stop the inverter. Everybody follow me?
Yes.
This is only for the charger located here for that group of batteries.
And so does the charge run through the same cables that supply power to the inverter?
No. Here you have the output cables for the breakers. You remember? The selector breakers. This breaker is inverter. This one is generator. And this one is short power, because you have the short power here. You know?
Mm-hmm.
Yes or not?
Yeah.
We have the 3 elements. Okay, this one is the output of this. For that reason, here you have AC hot in, AC neutral in, hot out, neutral out. You see? Out on top, in the bottom. Now in the breaker you can see in and out. Okay, the input is the power coming from the AC panel to keep the battery bank fully charged. Pay attention. Suppose that in this moment the inverter is not producing power. It's off because I am using the generator or I am using the short power. I have power in the AC panel. Yes or not?
Yes.
Because I have power in the AC panel, I send power here coming in only to keep those batteries fully charged. Additionally, I can install here a group of, what is this?
Solar panels?
Solar panels configured in series or parallel only to keep those batteries fully charged. That's additional.
So you'd have a set of solar just for the inverter batteries? Okay.
And you can install a lot of panels.
Would
and
you-
you say, okay, this section of panels is exclusive for the inverter battery charger.
And they would have to be exclusive. They couldn't charge a separate battery bank as well.
Or I can do this. This is the next class.
Okay.
I can configure a lot of panels, and all of those groups enter in a special of a.c.r, and you charge different battery banks.
Okay.
That's it.
Okay.